Hello, good day to you. Today, my demonstration is about the use of Linux network namespaces in Openstack. I have made a video before where I described how to use Linux network namespace. The network namespace basically is a logical copy of the network stack. So a network namespace has its own routes, its own firewall rules, its own network devices and IP address. So it is, in a way, you can think of it as, virtualizing the network stack. So OpenStack make use of this technology a lot. So, and that is what I want to show you, as part of my series on administration of OpenStack. So if you are working in OpenStack, I think this is one of the things you should know because if you need to troubleshoot the network, this is one of the things you have to really understand. So basically this is the OpenStack document page where it talks about network namespaces. So and give some definition. For example, say a namespace is a way of scoping a particular set of identifiers. So basically the identifiers we are talking about there are things like the routes, the devices and IP addresses. So furthermore, it talks, I think one of the greater points is here where it says each network namespace also has its own routing table. And in fact, this is the main reason for for namespace to exist. So the fact that the routing table of each namespace is different, that is one of the main reasons why this network namespace exists. So because if you take a look at another technology which is more or less the same, that is virtual routing and forwarding. So virtual routing and forwarding, basically is a technology that allows multiple instances of routing table to coexist on the same router at the same time. So it says it is another name for network namespace functionality described. So I hope you are able to understand uh, all this theory that I'm showing you. So now I will go to the terminal so that it will not be all theory, and I will be able to see some practical things. So like I said, network namespace is a core part of what of how the OpenStack neutron achieves a lot of what it does. So let's log in to my OpenStack. I have an OpenStack or Kata version here, and I'll go to the network or tab under the network. Uh, let's wait for it to load. But why it is okay, yeah, it is loaded. So on my network, I have two networks actually. One is int network, one is est network. Let me show my network topology. So my network topology will show how things are connected. So this is my network topology. So you see I have one router. This is the router 1. I have this is the int network and this is the est network. So now let me go to the terminal. This is the terminal of my OpenStack setup. If you are in a multi-node environment where you have separate nodes, this will be on your network node. This setup is like all-in-one setup, but I'm just telling you in case you have multiple nodes set up. So if I type IPNetNS, so IPNetNS basically stands for network namespace. You can type netns ls, the same thing. So you see there are two network namespaces here. One that started with QDHCP and the other one that started with QRouter. So the one that started with QRouter actually corresponds to this router here, my router 1. So if you look at the ID of this router, you see the ID ended with C7F8. So if I go to the network namespace, you see is ended with C7F8. So the other namespace, which started with QDHCP, corresponds to the int network, that is the internal network here. So there's no representation for the external network, only for the private networks and the router. So you see, I have two namespace that correspond to the one of the private network and one of the router. So, and this is very crucial. So, and one of the crucial things that namespace helps Neutron to achieve is we can have two subnets, two networks with the same addresses, the same exact addresses. This, they will be separated by the network namespace. We can achieve this by network namespace. So what I'm going to do, actually, I'm going to create two networks. So let me create one network. I'll call it the red network. Next, create the subnet, and here I'll give the network address to be 192.168.10.0/24. Next, so let's create it. That is my red network. So if we go back to the terminal, actually, waiting to think I lost my terminal. Let me give it some time. But you see, I created this network called the red network. Let me actually create one more network. Sorry, I think I lost my terminal. Let me log back in. I SSH'd into the terminal. So let me just restart my networking. So I have to restart my network on my system. Give me couple, like, one moment, because I need that to be back before I can connect to my Openstack server, because I'm connected to it over SSH. So, but somehow I lost my networking and I have to actually restart it. So restart the networking. Yeah, I get that. Okay, it's back. Sorry for that break in transmission. So I'll become root again. So I became root, and if I type IP netns again, netns, so you see now I have an additional network namespace. So I will create another network, actually, called the blue network, and I'll call it the blue subnet. I'll give it exact same network address. So I am able to achieve that because of the help of network namespace. So it is going to be created in another network namespace. So if I run IP netns again, you see now I have 4 network namespaces. So the network namespace that corresponds to the private networks, are the one that starts with QDHCP. The one that corresponds to the router is the one that starts with Q router. So you see, like the ones that the ones. So this is my blue network. You see, this is my red network. So look at the end of the ID. The ID is 40343. So if I go to my terminal, you see 40343. So that is how the namespaces are named. So it is named with something like QDHCP, then with the ID. So let me show you one more thing actually. So this network namespace, we can execute some things with on them. So if you need to execute something on network namespace, you run net IP netns exec. So exec, don't forget that. So the name of the namespace. So let's run something like IP address. So I'm running this IP address command on this namespace. So if you look at my IP address, you see all these interfaces that I have, and especially you see this IP address which corresponds to the IP address of the gateway of the router. So if I go to my router, so if I go to this is my router called router 1. So look at the IP address of the gateway. It is 10.20.20.6. So when I run the IP address under the namespace, you see 10.20.20.6/8. So that is a one way. So if you need to troubleshoot your networking, so for example, if you're having network issues, one of the things you can do, you can come under this network namespace and try to ping your default gateway. If this is so, if you are dealing with things like floating IPs, so this is very important. So for example, let me even I'm going to create an instance, and I'm going to attach uh, a floating IP to this instance. So quickly, let me create an instance. So I have options of network. So this is the network that I want. Okay, launch, that's fine. Then I'm going to attach a floating IP. So I will do associate floating IP. I select this. The port that I want is this associate. So while that is going on, if I go back to my network namespace and I run IP address again, you see under this interface, this particular interface, there is one more IP address that showed up. That's 10.20.20.3. That is the floating IP that I just created. So this is the way in which Openstack uses the network namespace to isolate the networking of different networks. To do the things like the floating IP. So one thing I can do, so when I say that I can run IP table command under this namespace. So if I run IP table -l, so you see this namespace actually has its own IP table, with which it's able to achieve a lot of what it does. So this topic might not be a very basic topic, especially if you are in the OpenStack arena. It might be a little bit advanced, so I don't consider it as an entry level topic. But if you really want to get into OpenStack, this is basically this is the one of the things you have to know. Let me allocate one more. Okay, don't worry. Yeah, I have to be able to attach it to. I've demonstrated, attaching. This is the floating IP that I created that was attached to the instance, and we can see it on the terminal when I ran the IP address. So let me under the pnetns exec, one of the namespaces. If I run IP address, so look at this IP address 192.168.1.2. Where does that belong to? So it is the IP address, that was allocated and attached to the interface of the router. So that's one of the interfaces. Actually, it's not. Let me see. I think it should be. This should actually be. Okay. Yeah. So okay, this is another concept of a tap interface actually. So which, yeah, I don't want to get into in this demonstration. So that this is belongs to concept of tap interface. So, but basically, I think that is what I want to show. Let me see if there's something else I can show that relates to this. So, so basically, for troubleshooting, I think that's like one of the most important thing. The troubleshooting aspect, that if you are having problem with your networking, one of the places you can come to check, to troubleshoot is under this namespace, especially the queue router namespace, because it is the one that handles uh, the floating IP, assignment, and all the NAT table that goes on. So, and that command I can run under it is the IP route. So basically to see the routing, that's available on this particular network namespace. So not to make this video too long, I think that is all I want to show. If you have any questions or any suggestions, let me know on the comment section. So thank you for watching. I'll see you. Bye.